Good afternoon. My name is Jared SCHNIERS. I'm the Alamito Creek Conservation Initiative Coordinator. I work for Borderlands Research Institute.
I'm Bryce RUMBELOW with Rio Grande Joint Ventures, so Migratory Bird Joint Ventures. We work on habitat restoration projects within our conservation delivery program for birds. So we're kind of here for the birds, but partnering up with BRI and partnerships is a lot of how we get stuff done. And so just happy to be here with them today. Okay, so healthy watersheds are vital. One of the things that we like to do is try to do conservation on the watershed level. So at that watershed level, what you're looking at is the area that influences a specific creek, drainage, pool, pond, whatever that might be. That would be its watershed. We like to think of that in kind of terms of water catchment area, though, instead of watershed, right? So whatever is going to be in your creek is caught in that area. Think if you're a drop of water, you roll down to the creek bottom.
Yeah, so a lot of what we're trying to do here is mitigate some of these erosion and try to get more water stored into the ground and in these creeks and draws. So why do rangelands erode? A lot of it we're seeing a long periods of drought and then extreme rainfall events, and a lot of that water just runs off. We have very highly erodible soils. If there's not any kind of vegetation or cover there, no roots holding that soil in place, we see a lot of runoff from these rainfall events.
Yeah, and so I should have backed up a little bit, but Dr. Frank did so good kind of explaining the importance of those big open grasslands to y'all. So I'm kind of getting through that and getting down to that creek level. But this is a really good image which shows kind of what's the difference between a functioning versus non-functioning creek. So if those watersheds aren't healthy and they become very flashy, the systems, so that water, it'll get into your creek in one big rain event. It comes down, it has a lot of velocity, and it has a lot of potential for scouring. As it gets into a channel and it begins to scour the bottom of the channel, it can no longer access the floodplain. The floodplain is the creek's natural place to dissipate energy. So if it can't get out of the creek and get onto the floodplain, then all that energy stays in the creek and down cuts. What happens is over time, it gets deeper and deeper. And as you can see in this graphic here, the riparian aquifer follows that level down with it. And so now your floodplain plant community can no longer access that water that's stored in the riparian floodplain, and it dries out, which kind of starts this negative feedback loop. You'll see this on a lot of ranches out here where the only species persisting on those gully edges are your mesquite, because they have that long taproot that can grow down, but the grasses and the more beneficial shrubs will go away over time.
Yeah, so here's some pictures kind of what we see. This is kind of a head cut, which just starts a big, long channel of erosion. But yeah, like Bryce was saying, it lowers the water table. You no longer have that vegetation establishment. You're not getting the water up on the floodplains to hydrate the land, losing that vegetation. But this is kind of typical of what we're starting to see and dealing with in Presidio County in the Alamito Creek watershed.
Some examples of that. This is on the MIMS again above Marfa, and what you see in the bottom right-hand corner is a gully that is formed. We've worked in this drainage, and we'll talk about it a little bit more. But once you get to this point, there's not a whole lot that you can do. So we like to work above gullies and in the grasslands to slow and spread that water before gully formation happens. Here's a picture in Terlingua on Rough Run Creek. circa 1970 over there on the left-hand side, and today where TxDOT has just chosen to put a bridge over this 20-foot gully and, carry on, because, like I say, there's not a whole lot you can do with it once you've got to that point.
Yeah, so that kind of leads up to where we're at, trying to restore some of this erosion and these problems we're seeing. So low-tech process-based restoration practices, we're implementing brush weirs, one-rock dams, Zuni bowls, media lunas. These are all to slow the runoff, catch sedimentation, and rebuild vegetation.
Yeah, and this image, I'll say it was done by Heartwood Visuals for a USGS paper. This is public source data here, but it's really good image, and it illustrates very well the different types of structures that you can work with. We like to work as high up in the watershed as we can to start to slow that water down. Leaky weirs, trincheras. BRI has had a lot of success with trincheras on some of the ranches down south. One rock dams, we do a lot with those, and we've got a lot of success. Log dams over here, you've also heard those called beaver dam analogs in the literature and things. But the idea behind all of these is that these are leaky structures, right? We're not trying to hold back the water in maybe what you've seen on header dams and things like that. These are things to really just slow, maybe mine some of that sediment out of the water, aggrading the bottom or lifting the bottom, and just increasing the retention time. And what it does is it allows that plant community, that vegetative community near those structures to respond to that increased availability of water. Now, what happens is, as they respond, they start to shed material back into that creek, which increase the roughness further. And so what will happen is, over time, your structures will kind of get covered up by vegetation. That's a good thing. And the vegetation is better at filtering out that sediment and slowing down that water.
Here's an example of a brush weir. In some of the other western states, Idaho, Montana, they have beavers, and they'll call them beaver dam analogs. Anyway, they put them in streams that have live water, but we're putting them in some of these areas to slow runoff, capture sediment, and eventually hopefully hold the water for a longer times. So anyhow, this is a picture of a brush weir where we're weaving brush. Typically, you like to use juniper as the brush we're weaving between there, but used to kind of catch that debris and start growing vegetation where in the channels there. So
rock is another medium that we use. Sometimes branch mulch is not available or brush isn't available near your site. Sometimes the underlaying bedrock material is close to the surface and not appropriate to drive in posts and weave your branch mulch. So in those cases, rock is a really good alternative. I'll say that picture on the left there was installed 24 hours before the rain event that filled it in. So once we had that structure in place, we caught 1.5 feet of sediment going back 25 yards behind the structure in one rain event. And here's another good example of a site that was designed by Bill Zedike. He wrote the book, Let the Water Do the Work, with Van Clothier, which is a great resource for anybody who's interested in more of the technical aspects of designing these structures. But you can see, going left to right, bare limestone structures were installed, and then the vegetative community response. And you no longer see those structures under there, but they're still doing the work. And now they're aided by the vegetation that's doing the work.
Here's so the brush weirs, the one rock dams. Typically, we're putting those in stream channels. This a media luna here, half moon, but these are used to. We kind of put these on uplands, on an upland side on the Mims Ranch. We put a series of 10 of these in. Same concept. To slow the runoff. We see a lot of surface runoff on some of these uplands. The water sheets off pretty fast, so these just help dissipate that.
Yeah, and that's a before and after there. And this is above that gorge that we showed earlier. That that gully that had formed on the Minch. Yeah, so Zuni bowls. This is another one that we use. A head cut is kind of a physical phenomenon where that water falls off of a lip. As it does, it generates a little bit of turbulence, and the turbulence erodes the base of that lip. And so the erosion happens upstream or towards the head of the creek, hence the name head cut. What you can do is you can armor that lip and create a little armored pool for that to fall over. What's interesting is as the water falls into that pool, it creates more of a pillow for that next water drop to land on and then go down. What happens is you'll arrest that head cut, you'll stop it from increasing, and so this can be a really valuable tool. You'll see it along ranch roads where maybe the upslope side is shedding water onto the road, then downslope it's falling off, and you can arrest that, saving your road and reducing your costs long term.
Yeah, so some of the benefits we're seeing from doing this, we're hoping to increase that amount of diversity of the vegetation, improve the soil health, and then lead to a more resilient landscape overall, better wildlife habitat. Habitat are more grass for the livestock also. So in 2023, we started with the Alamito Creek Conservation Initiative. It was a grant with the Dixon Water Foundation and the Horizon Foundation, with partnered with Rio Grande Joint Venture, Borderlands Research, to start implement some of these restoration practices in some of this erosion area down south of Marfa in the Alamito watershed.
Yeah, the Alamito Creek watershed, it's quite large. It's 1 million acres. I think we're running out of time here, but I'll tell you, since we got started, we've worked on 7 different ranches, put in 120 structures on 5 miles of stream, and about 6,000 acres of grasslands treated. And these are going to be those grasslands for your grassland obligate bird species. And I will just take a minute to tell a quick story here. When I was with the state parks in Region 1, I was doing fish surveys in Alamito Creek on these perennial pools that were holding fish within Big Bend Ranch State Park. So in that kind of epic 5-year drought that we had from 19 to 24, those ephemeral pools are no more. So part of the reason why we chose Alamito Creek is because we're kind of right there on the cusp of losing a real gem to the area. But we haven't lost it yet. There's still those perennial pools.
Yeah, so where do we go from here? We're continually looking for funding and money. We have it available. If you have property, a landowner in the Alamito Creek watershed, or you're interested in controlling some of these erosion issues, come talk to us.